Okay, tonight we're going to talk about Git. Yeah, it's time for some version control. Um, so the source code system, Git, the distributed source code system, uh, it was requested from a friend of mine that it should be the next topic about what we address here. After Gopher, I guess it's the next logical step. So I'll do my best. I'm going to give you an overview tonight about where it came from, some basics on how to use it, some strategies for how to use it, branching, the styles of commit messages, how to make working on a team a little bit easier, some of the techniques I use, and we'll do a little bit of like advanced touch at the end. Okay. Unlike my last video, I actually put together a little bit of a little helper for myself here. Some notes. There we go. On the right-hand side here. This is what we're going to talk about tonight. Overview of Git, creating a repo, branching strategies, aligning those branches to environments versus just using feature branches, and proper commit messages. And then finally, we'll end with a touch of rebasing in the way that I like doing it, not the way that the rest of the internet likes doing it. So, that's how we roll. All right, so what is Git? Git is version control. It is just like CVS or SVN. It is a version control tool. You are writing code, you're writing stories, whatever you're doing, you want to be able to keep that revision history safe. You want to keep it off of your machine, hopefully. Have a backup for it somewhere. Yeah, hey, you can see my music playing up at the top. That's cool. So Git is great. It's great. Linus Torvalds came up with this one. This was his big follow-up to Linux. So it's a distributed system. That's the big differentiator from most of the others out there. That means that I can have a complete copy of the repository of all of the code, and you can have a complete copy of the repository. We can work independently, and we can sync up and share the activity that we've done kind of through a web. And that can either happen through kind of a centralized remote place like a GitHub or a GitLab or a Bitbucket. Self-hosted option, Stagit, I don't know how to pronounce that one. Oh boy, what's the one that the Tildeverse uses? Well, I always have to forget something in these videos, but there's a bunch of them that are available to you. Or you can just use Git like on your machine without one of those fancy remotes. You can set up a remote, headless remote on one of your web servers or on a VPS somewhere. Push code back up there. You can run it locally on your machine. Somebody else can run it locally on their machine, and you can email changes to one another and manage stuff that way. And that's actually how most of the Linux kernel is managed. It's over email, which is kind of cool. So there's a lot of different strategies of how distributed comes into play. Remotes are probably the thing that you're going to deal with the most commonly if you're using Git. You're going to touch GitHub at some point. You're going to touch tilde.git.org or whatever, and you're going to need to know how to deal with that. So I'm going to kind of start there, and let's create a repository to get started, okay? All right, so this is my GitHub account. Welcome. Over here, I'm going to click this little plus guy, and I'm going to create a new repository for us. No template or anything. I'm going to be the owner, and we're going to call this one PeerTube. All right, because we're on PeerTube. And I'm not going to do anything special here. I'm just going to click Create Repository. Now, because I'm doing this on the remote, I don't have the Git repo, the repository, on my machine yet. I need to connect to it. And so it'll tell you how to do that here if you've done this kind of thing before. You can grab this, and we'll do that in a second. Or you can create the repository in the command line. You'll see what they're doing here. They're creating a README file. They're initializing a Git repository, adding that file, committing it, pushing that, or adding the origin to this thing here, and pushing the change up to the master. We're going to kind of do all of that, but I'm going to walk you through what each of these things are and what they're doing. So to start off, I created this remotely. So let's start with the most common method that people get started with, and that's just cloning the repo down, okay? So I'm going to copy this. This is the SSH connection to this repo. If this were a repo I didn't control, it might be an HTTPS link, but either one is fine. Basically, Git doesn't care about how you get to the repository. You can technically fetch this over FTP, but the most common methods of dealing with remotes that you'll see are either HTTPS or SSH. SSH being probably the number one. So I have my SSH key set up in GitHub so that I can do this without having to, put in a username and password or anything. So I'm going to copy that with this little click here, which is the same as just copy, right? And I'm going to jump back over into my my terminal, and I'm in my personal sites folder here. So I'm going to run a Git command called Git Clone, and I'm going to paste that link, okay? And what that's going to do is it's going to clone that remote repository down into a folder here on my computer that uses the same name, PeerTube. See? So now I'm in there, and here we are. There's nothing in it. That's it. Congratulations. What you can do is run a git status, which will show you that, well, we are in fact in a Git repository. We are on the branch called master. There are no commits yet, and there's nothing to commit. These responses you get back from Git commands are actually really helpful and descriptive if you read them. A lot of people just kind of brush past them because it just seems like a lot of information, but they actually tell you like how to do the next step in most cases. And part of that is your own personal configuration. You can tweak that language. You could say be really verbose with me, or keep it minimal if you're used to what you're doing and you just want to keep the messages slim. So anyway, if we were not in a repo, let's say we're back in my personal folder and I did git status, it'll fail. It'll say we're not in the Git repository. So that's good to know, right? We are in a Git repository, git status, there we go. But there's nothing in it yet. So you can see that both here on the terminal, and you can see that here on the actual PeerTube remote repo that we made. All right, so let's add something. I think we should start with a README file. Okay, so README, and I'm going to make a markdown README, and I'm going to say PeerTube sample project. Can't type when I'm on a video. This is a sample project that I'm using to illustrate Git in a PeerTube video. There we go. Perfect. Right. Now, if we take a look, that file is there. And if I run a git status again, this is kind of like the default command for just checking what the relationship is from your files to your repository. Well, now we have some new information. We are on branch master still. We don't have any commits yet, and we'll talk a little bit more about what commits are in a second. But then we see this untracked files, and it tells you what to do. Use git add file to include in what will be committed. Well, the wording's a little strange, but that's it. We can use git add and the README to add that file into the repository. So let's do that. Git add README empty. All right. Now git status. Let's see what changed now. All right, we're still on the branch called master. We'll talk about branches soon. We still have no commits, and we have changes to be committed. Okay, so git rm-cached file to unstage. Well, this brings us to our first lesson about how Git is organized. There's basically three environments that you're working on with regard to a Git repository. There is your local files. They're most often, untracked or unmodified files on your system. There's this in-between step before something is pushed into the repository called staged. And that's what we've done by adding. Nothing's actually in the repo yet. We've set up the repository with a change. And that change might be one file. It could be 100 files. It could be 1,000 files. It could be some files being added, some being removed, some being changed. All of those changes here are staged together. So we have this right now. The staged state is one file, which is a new file called README, and it's a markdown file. If we want to add that into our repository so that it's tracked for the future, then we need to commit that change. So that is a commit. Commits are organized by kind of this hash thing. Instead of like SVN had a specific number to them, like a sequential number. Because Git can move history around and it's not necessarily linear, that numbering system doesn't really make sense. So they use these hashes, SHA something, SHA, I forget which SHA hash it is. But regardless, it's a big long string of crap. And we'll look at those in a second. Those are a little weird to deal with at first if you're coming from an SVN and you're trying to figure out, what order things go in. But I'll show you how to look at logs, and we'll look at stuff in GitHub as well for that as well. Let's commit the file now. All right, so git commit readme md, right? That should do it, right? Well, actually, it does. That's it. But we've got this special message here. Please enter the commit message for your changes. Line starting with a pound will be ignored, and an empty message will abort. Oh, see, again, helpful things we can actually read. It tells us we are on the master branch. This is the initial commit, and this is the files that are going to be committed or changed. So all of this information is not going to be in our commit message, but it's helpful information for us to make sure that we're in the right spot. Now I'm going to add a message now in Vim, and I'm going to say adds README to package. Now just to say adds README to explain purpose of repository. Okay, that's it. I'm going to do that. I'm going to save and quit. That. Let's see. What is this done here? Master root commit, and look, there is some cool SHA hash stuff going on. Adds README to explain purpose of repository. Yes. One file changed. 3 insertions. That's actually the number of lines that were inserted. So that's the plus. And it tells us the file mode that it was added in with. Okay. So if I do a git status again, well, now this is all new. Your branch is based on origin master, but the upstream is gone. What? Well, that's strange. Let's talk a little bit about upstreams. Let's talk about upstreams. So I did all this change. I committed a file. It is pushed into the repository, so I should see it here on the row, right? No. So remember when I said that Git is distributed? The repository that's running on the remote, in this case GitHub, is separate from the repository that's on my computer. When I'm dealing with Git on my computer, it's on my computer. Everything that I do with Git is on my computer. Committing new things, changing branches, making new features, merging things, all of that's done locally. And it's powerful because it means you can be offline and you can get a lot done. You can do a lot safely with version control. You can roll back changes, try to make a fix and merge that into another branch. All of this stuff can be done locally on your machine. And then when you're ready to propagate that change up to your team, you can either send them a patch over email, like you might do for the Linux kernel, or you can push that change up to a remote like GitHub, or you can make a pull request, which we'll talk about in a little bit as well. So in this case, we're going to push our change up to our remote. So I'm going to say git push, and we're going to push to our origin remote. Now, why is it called that? That's like the default name. So if I do git remote and just hit enter, look, our remote is called origin. Git remote -v. So verbose remote will tell us that origin for fetching and pushing is this thing. Remember, that's what we used when we cloned our repo? That's our reference to a remote. Now, you might have more than one remote. You might keep a copy of this repository that is locally on your machine up on GitHub, up on Git, up on Bitbucket, up on GitLab, all of them, right? So you could actually create new ones here. You can just do Git Remote Add Bitbucket, and then you would put in the git at bitbucket.org, I forget what that is, and then whatever the path is to it. And then there would be another set here. So when we want to push a change up from our local repository to a remote, we're going to use the push command, and we're going to tell it which remote we're going to go to. So git push origin, and finally we want to tell it the branch name that it's going to go to. Branches are really important in Git, and if you're coming from perhaps a really big repository in like SVN, branches came up very rarely for you, most likely, and they were kind of scary things that you had to deal with. Not the case in Git. In Git, branches are your friend, and you're going to do lots with them all the time. You're going to be creating them, destroying them left and right, merging them in, rebasing them, all sorts of things. So, branches are cool, but just like origin is the default name for a remote in Git, the default branch in Git is master. It is the master branch. So I'm going to stick with master for now, and we're going to push our changes, our repository, from our current branch, which is master. See, we're on branch master. We're going to push that to the origin remote to its master branch. So when I've done that, this is what happens. Counting objects, 3, done. Writing objects, all that's cool, total. Look at that. And we've pushed it up, and on the remote, there is a new branch called master. Now that's cool. So if I go back over here and I were to refresh, now, look at this. We are on branch master. There is now a readme MD file, and we can preview it. And because it's marked down, GitHub will make it all pretty for me. Nice, right? That's really cool. All right, so not so bad, not so bad. Pretty easy stuff. So let's see, what did we talk about here? We talked a little bit about Git, the fact that it started with a lot of store folds, that it's distributed. We talked a little bit about a remote. We created a remote. All right, let's talk about fetch first pull. So when I first created the repository locally, I cloned it from a remote. That's kind of a cheating way of doing it. So let's go ahead and remove this from this thing here. -rf peer tube. We're going to get rid of it. And I'm going to go back up here. And I'm going to go blow this away on GitHub as well. Delete this repo. Definitely type this in by hand. Definitely don't copy and paste that, because that would be really dangerous. Okay. Yeah, we'll confirm that. Let's do this all kind of the opposite way. We're going to create it locally first, and then we're going to push it up. Okay? So let's see what that looks like. I'm going to make directory, peertube. We're going to change to that directory. There it is. And now git status. Is this a Git repo? No, it's not. So how do we make it one? Well, we say git init. Initialized empty Git repository. And this is kind of a neat thing to know. Everything that is about the Git repository is stored in a .dot file in the folder called .git. It is a folder in itself, and if we were to look, there it is. Don't mess in there, unless you later learn what you're doing and you're making like hooks or something. Just don't go in there for now. It's safe to avoid. All right, so we have it, git status, and we're back to this state again. Nothing's there. So we're going to go ahead and make, we're going to vim readme.md, peertube repo of examplitude, example, okay? And then git status again, and this is back to where we were before. So I'm going to say git add, and this time I'm just going to add everything. All right, it's a little cheat. If you have a whole bunch of stuff you want to add and you don't care, you're just going to add everything. Done. Git add dot. And then I'm going to say git commit -m for the message. I don't want to open up that whole window again and enter my commit message. I'm just going to do it right here. And I'm just going to say adds readme. Okay. And that's it. It didn't open up an editor. By default, Git will use whatever is in the editor environment variable, which for me is NeoVim. If you're using a GUI, it'll pop the GUI up and you can work in there. That's all tweakable as well in Git configuration options. But, there we go. So now I want to push this up to a remote. I have an option. I can either create the remote here, which is usually the safest way to do it. I would just create a repository again, and then I would add the remote and push up. There are ways to do it using the GitHub API. Different things work different ways, but let's just do it this way. Okay, PeerTube. And this time we're following more of the steps that were down here. We created our thing with Git init. We added a README. We did a commit. Now this is what we're going to do. Git Remote Add Origin. We saw a little preview of this before, but we're going to do it for real now. So I'm going to copy that guy, pop back over, and we're going to create our origin. Git Remote Add Origin, and we're going to paste that in. And now when I say Git Remote -v, there it is. Git push origin master, and there it is. And we refresh this guy, and we have PeerTube repo of Exemplitude. All right, Exemplitude. Yeah, I think that works. Okay, so that's two ways to make a repo. If you start locally and then you later on want to create a remote, that's just how you do it. If you want to create the remote first, clone it down, and then work from there, that works as well. So it's kind of whichever you feel like. Now, we've used push, but we haven't talked about fetch. Fetch is the opposite of push. If there are changes done on the remote end and you need to pull them down, you fetch them. Let's take a look at that. Let's edit the README on GitHub by just saying examples are cool, okay? And look, this is the commit message right here. This is a graphical version of it. We're going to commit it directly to the master branch. That's fine. And we're going to say changes README description. There's not really a good reason for this. We'll talk a little bit about what makes a good commit message later. This is not one of them. All right, we're going to commit that change. So now what has happened is we have more history. If we were to look at the history, in fact, for this README file, we'll see there was originally the adds README, and now there's this one, changes README description. 3 minutes ago, 12 seconds ago, and these are those SHAs I was talking about. We can actually, on GitHub, we can browse the entire repository at this point in time. We can jump back to this point in time. All cool stuff. But we made that change on the remote. Remember, that is a separate repository from the one that is on our machine. We need to get those changes down. Now, there's two ways to do that. There is the kind of the bulldozer technique, which is just give it to me. I don't care what's going on. Just give it to me right now. And that's the opposite of push, which is called a pull. So if I just said git pull, technically git pull origin master, because that's what I'm pulling down. If you properly set up your remotes, you don't need to specify the branch name or even the default remote. You could just say git pull, but to be specific, it's git pull origin master. What that's going to do is it's going to take all the data that's on the remote, pull it down to my local repository, and then it's going to just merge that change right into my local environment. So it's actually a two-step thing happening in one. The first part is the fetch, and we're going to do it one at a time so you can kind of see what happens in a pull, but one at a time. So if I do git fetch origin, that's going to go to the remote. It's going to fetch down all those changes, and you'll see from this remote, it grabbed these changes from here to here. And that is being stored in origin master. So we have those changes locally, but if I were to look at the README, they're not here yet. They are locally here on my machine, but they haven't been reflected in the code that we're dealing with. And that's part of that whole branch logic. So if I said git branch, we're on master. If I wanted to see the branches on the remote, there we go. There's origin master, right? Technically speaking, the fact that this knows there is a remote branch on origin master, it's not actually going out to the server to look at that. It's looking at my locally cached version of the remote's information. So this branch information here is on my machine still, even though it refers to that remote called origin on GitHub. And when we fetched it down, we just updated that local cached version. So we can always stay up to date by fetching and fetching and fetching, and you're good. Like, you have the latest. Great. Now to bring that change in, git branch, remember, we're on master. We want the changes that are from origin master, so we can merge those changes into our branch by saying git merge origin master, because that is the name of that remote branch. That has fast forwarded. It's automatically determined the change that we're merging in doesn't conflict with anything else that's going on our in our current working environment. And so we can just fast forward those changes and apply the commits as they are. Doesn't need to create a new one, doesn't need to do any kind of fancy work. Boom, one file, one insertion. And if I look at that README, there it is. Examples are cool. Now let's do this one more time and I'll show you the pull method. So we're going to edit this guy. Examples aren't cool, they are super cool. All right. And we're going to say adds super. Again, we're going to commit directly into the master branch for now. Now, we want that change back over here. So this time, I'm just going to say git pull origin master. Instead of fetching it and merging it, we're going to do it all in one step. And that's what just happened here. Branch, master, fetch head, pulls in these new commits. And then there's the fast forward. So it actually did the two steps for us all in one step. A lot of times you can get away with a pull. If you are working on an environment with a lot of other people and you're in a more sophisticated branching structure than just what I'm doing right here, then you might want to fetch, might want to inspect what's going on a little bit before you decide what you're going to merge in. You want to make sure you're merging the right remote branch into your local branch too. And that brings us to branches. So that's a fetch versus a pull. Let's talk about changing branches, right? Git status. We're on the master. There's nothing to commit. Our working tree is clean. That's the working files is what I was talking about before. That's stuff that's not staged, not committed, right? It's local messy changes. We're clean. We have nothing different from what's in the repository. Good to know. Good to start from. Now this time, let's say we want to add a new file, and this file is going to be, I don't know, it's just going to be a list file. But let's pretend for a moment that we're working with other people, and we don't want to interrupt the work that's going on that they're working on. So we're going to create our own branch. We're going to do our work, and when we get it just the way we want it, we're going to bring it back into this master branch, which is what we're going to think of as the main live branch, or the main public branch, right? Everything else is kind of our own private playgrounds, but this is the main one that people are going to use. So how do we do that? Well, we can create a branch by saying git branch and a branch name. Let's say lists. And let's see, git status. Well, nothing changed. We're on branch master. But if I say git branch now, look what's changed. We now have two listed here, lists and master, which is highlighted as a star because we're still on the master branch. We created a new one called lists, but we haven't switched to it. Now, how do you switch to a branch? This gets us into the first major criticism I have for Git, which is The terminology that they use for the different commands is incredibly esoteric. It's really hard to remember everything. I mean, as you start using it, there's going to be 10, maybe even 20 commands that you get to know pretty well and you can remember. But once you need to do something out of the ordinary, chances are you're going to have to look it up, and it's going to be weird. It's going to be named weird. It's going to have like a unique syntax for the switches in it, for everything. And there's even a joke site that's out there. It's a machine learning generated fake Git documentation, and it's hilarious because Git documentation is so esoteric that you can't really tell the difference at first. And you can send that link to people, and if they're not familiar with it, they'll often think like, "What is this? A new obscure Git command?" Yeah, it's that bad. So the one we're going to need to know to switch branches is called checkout. Git checkout, all one word, lists. Switch to branch list. See, descriptive, helpful. And if I do that git branch again, now we see we're on lists. Now, some people will have, like in Z Shell or even in Bash, you can actually put the current branch name into your prompt, and I did that for a really long time. It's very, very helpful, especially if you're getting started on Git, just to keep yourself oriented. Where am I? So, feel free to use that. It's not bad. I've gotten to the point now where I don't need it, and I like to have my prompt a little bit cleaner, so I took it out. But now that we're on the lists thing, let's see what we want to do. Let's make a new file called lists. So vim lists. This is a list. Good. Now I just typed GS there. That is an alias that I've made for git status, because I type git status a lot. So I made an alias for it. That's all. So we can add this file just like we did before. So I can say git add lists. I could say git add dot, or I could say git add -a, which is git add all new files. Lots of different ways to git add. And then when I do this again, I see there's a new file. If I wanted to step backward, I could do this git reset head, and that will unstage. So it'll take it out of my list of things to be committed, but it won't revert the changes that I made. It'll just go back to this previous state. It'll still have all the file stuff there. But we're going to go for it. We're going to say git commit -m adds initial list. All right? And we're going to look at that, and let's not push it up just yet. So we're on our own branch. Right now, that branch does not exist in the remote, this lists branch. We only have master over here. But we have our own special branch that we're working in. Now, if I wanted to, I could edit this list file again and say, you know what? These should all have dashes in front of them because it's a list, right? All right. So then the git add -u is a switch that will only add to the staged environment files that have been updated. So it will not add new files like lists was last time, but this one is modified. So basically it says stage everything that was modified. And if I see, look, there it is. Git commit -m. You know what? Let's do it the long way again. Git commit lists, and then I'll pop this up again just so you see it again. And we're going to say prefix list entries with a dash. Okay. And that change is made. Right. So again, still nothing pushed up here. We do not have a list branch yet. It is still here. And you know what? I realized one more change I wanted to make. Let's look at this guy. All of these should start with a capital letter, right? I think that's just the right way to do a list. This is a list. And let's get rid of the trailing space. All right. Now when we look at it, we can say git add -u, git commit -m, start list items with capital letter. Okay. Cool. So now I just did several commits to get to my list where I want it to be. And the reason I did that, it was on purpose. I wasn't just being, silly and doing nonsense. This is the way I develop. I will create a branch like this lists one where I start having an idea of what I want to do, and I'll make little iterative changes, and I'll change my mind, and I'll tweak stuff, and I'll continuously commit as I'm going. And it might not be working yet, but I've committed. I haven't pushed yet, but I've committed these changes so that if I need to roll back to an earlier state, I can. Rolling back to an old commit is a pretty standard thing in Git. Checking out an earlier version to grab something and then rolling back forward, moving commits around, or even you might go down a branch like this and have 10, 20 commits and realize, that was a bad idea, and just abandon the branch, move on, and then realize like 2 weeks later, oh my God, I had started some work on this that was actually valuable. You could jump back in time to that other branch, grab those changes, and directly apply, just one or two of them to what you're working on now through a thing called cherry pick. That I'm not going to go into any of that stuff tonight, but it's really, really powerful to keep track of what you're doing. I don't want to merge this in until it's a working thing. I don't want to pollute the Git repo with a bunch of in-progress stuff. What I do want to do, though, is clean up my work before I push it up to the remote. So I mentioned we were going to talk a little bit about Rebase. I'm going to jump ahead to that and just show you what that looks like now. And the way I'm going to do that is by showing you the Git Log. So Git Log. This is the normal Git Log, and I can actually page up and down. There's not much here, so this fits on pretty much one screen. If you look down at the bottom, this first commit you'll notice is really long. Typically, when you're looking in a GUI like GitHub, you only see the first several characters, but it's actually short for this entire thing. We could see that adds README, changes README description, and adds super. These were all things that we did that are reflected on our remote. These also where we left the master branch. So it tells us in our log a lot of really helpful information, right? And then we see these other commits that are happening later. These are not reflected in this. That's cool. That's really helpful. These commit messages would allow us to jump around if we wanted to. And we also get this nice description that is our commit message to let us know what we were doing and when. So before we get into the meat of Rebase, as I'm talking about all this, let's just talk about commit messages for a moment. When you're looking at Git history, it is often like this. Sometimes it is like this. But you see, that first line of the commit message, that's what you see. That is all of the information you have to judge what was going on at a point in time. And so it's vitally important that you write good commit messages if you want to have maintainable code and repos that you can move around in and do all of these advanced things with. When the time comes for you to figure out how to fix that bug that you introduced 2 months ago that you didn't realize was a bug, you're going to really, really thank yourself if you wrote good commit messages. Now, there's a lot of advice on how to write good commit messages. There is this one here, which I like. It's the 7 rules of a great commit message. Now, we've been writing subject lines. That's that first line. That's the summary line that you see in Git Log or in the history in GitHub. But you can actually write more. After you finish that first line, which is kind of like the quick hit of what this is, you can write additional paragraphs. Those will all be stored. They're stored as the body of the commit message. And you can see them if you dive in with a little more detailed tool. You can do that in GitHub. You can do that in command line tools as well. Keep your subject line, though. The most important thing is the subject line. If you never write the rest of these, maybe you're on a small team and it's just not a thing you guys do. At least focus on learning to write really good imperative subject lines. They're actions that explain, most importantly, what you did and why. What did you do in this commit and why? If the why is obvious, think about if it will be obvious in a month or in a year, because you're going to need to know, right? If what you did is all that really matters, then that's fine. Don't bother writing how, because the source code will show you how. So focus on what and why. Think about other people that are going to read your code. If your friend is going through this, will the what and why of this commit message tell them what they need to know? Okay? And if it's hard for you to answer what and why, the problem is most likely that you did too much in this commit. Commits should be thought of as like atomic standalone changes that you could pull out and move around and plug in somewhere else. So if you have a page and you need to fix a bunch of CSS styling on a website, don't do that all in one commit message. Focus on a concrete component. You know, I need to fix the positioning of the menu. Done. One commit. I need to adjust the spacing after headers. Another commit. It seems wasteful, but it's not. It's actually really, really important, because if one of those changes needs to be reverted or changed later, you can do that really easy if that's one commit. If it's not one commit, if it's a bunch of commits, there are ways to do it, but they get much more complicated very quickly, and it's such a pain. So, little changes, commit often. Now, that is not to say that you should commit after every line you change. Just like we've witnessed here, we have a lot of changes that didn't really do anything, like adding the list, prefixing it, and capitalizing it. That really should all be one commit, shouldn't it? And I'm going to show you how to do that in a minute. We're going to squash those 3 commits into one. We're going to kind of fix what we did before, okay? So I talked a little bit about commit messages, and then I talked about organizing your commits. Yes, atomic, individual elements. These 2 things, they seem like the simplest things I've mentioned tonight. This is the most important and hardest to train on a team. If you're working with other people, talk about what your strategy is with one another for those commit messages. If there are more senior people than you on the team, defer to them. What's been used on the project so far? Is it working? Did something bite them in the butt before? Do they want to change it? You know, have that conversation. Then really hold each other accountable, because you're going to be looking at each other's code, right? So if you see somebody that's getting sloppy and they committed something that says changes, no. Yeah. All right. Branding strategies and alignment environment. Okay, we'll get to that in a minute. All right, let's take a look at this little fancy guy for a second here. I'm not going to explain too much about what the command is and the syntax for it, because it's a little above what we're doing right now. Let's see, Git Log. Yeah, no, I meant to do this. All right. So what I am going to do is, let's see, add super. Good. Adds initial list. That's good. All right. What I'm doing here is an operation called a rebase, and it's an interactive rebase. Just like every other command in Git, though, if you do it the right way, it gives you help contextually. If you read what it tells you, it's fine. So what's happening here is at the top is the older commits, and they work down to the newer commits. I've told this command to look back in time at the last 4 commits, because I knew I wanted to mess with the last 3, so I like to usually go one past it. Now, if I just save this file right now, it is going to keep these commits in this order with these commit messages. Basically, it's going to leave everything the way it was. But I don't want to do that. I know that these 3 things should be one commit. So what I'm going to do is I'm going to change these to S, which is squash, which says use the commit but meld it into the previous commit. So both of these are going to get melded in with this, with the adds initial list. Now I could also reword this one here. I could do the R, which would allow me to edit the commit message, but I know already that when I do squash, it's going to give me a chance to do that in a second anyway. So I'm going to save, and this is what it does. It kicks me back into here, and it says this is a combination of 3 commits. So it gives me all the text from those 3. Now in this case, I don't really want to keep all of this stuff. I'm just going to say adds well formatted initial list, right? And this, when I save it, has rebased and updated. Sounds fancy, right? Well, check this out. If I do run git log, now we have our initial 3 commits. we got the same way to origin master and master, and now we have one commit that represents all of our good work on lists. This is something I use a lot on my own personal branches before I push them to the remote. This operation that I just did changed the commit message. It changed the history in the repo. That is dangerous. Rebase is inherently dangerous. Be careful with it. If you are going to rebase something in your local environment before you push it to the remote, you're safe. You're fine. Once you push it to the remote, if you rebase something and you change commits, you're going to end up in conflict with the other people in their branches. They're going to have other commit messages that are trying to affect the same kind of changes you're doing, but they won't align. And then you're going to get into trouble, and you're going to start Googling for hours and try to figure out what's going on. And eventually somebody's going to call up a friend that's been using Git for a couple of years, and they'll be like, oh, yeah. And they'll either have you reclone the repo, or they'll force you into some backward operations where you roll back commits and then reapply them manually. And it's time-consuming, it's wasteful. So just be careful with it, okay? Using it on your own private little branches in your local environment, though, to clean up your work, that's great. You want to get to the place where you have a single commit that represents what you want to do, and then you can push it up to the repo. So in this case, I'm going to do that. I'm going to say git push origin, because we're pushing it up to the origin. But what branch were we on again? Lists. I just used tab completion there, and it actually told me the names of all the different branch possibilities. So I'm going to push our lists branch up to the remote. And when we look at it, and we refresh, we'll go back to here. Oh, look at that. You recently pushed branches. Compare and pull request. Cool. There's list. All right. So that's the typical log. You can also reformat log in different ways. So git, let's see, LL? No. Which one did I do? Git LP? Here we go. I have a bunch of different aliases that I use for different log formats. This one, I've got my camera here in the way, but this one I like because it tells me the author of each commit. It tells me relative time of when they happened. I like it, and it collapses everything down really nicely too. Let's see, git. Let me see here. Config git config log. Let's take a look at some of my log ones. All right, so I have LG and LP. Is that all that I did? Okay, I thought I had some other fancy ones. But you can see the actual Git log options are fairly ridiculous. Pretty format with color settings here. They can get long, but if you write yourself helpful aliases, then they're really helpful. So git LG, I use this one a lot. Gives me kind of that short version. There's also a nice command line program called TIG, which is a graphical, end curses style thing that'll let you kind of browse around. And I can click in on here and see the different changes that happened and browse it. There's a very powerful tool. You can use a bunch of different stuff, a bunch of different options and whatnot in here. So I like TIG. And of course, there's always the browser as well. So let's say I wanted to take my changes in list and I want to apply them to the master branch. There's a couple ways to do that. We saw a merge before. And if I wanted to, I could git checkout master. And you see the list file's not there. And then I could git merge lists. Now, the way merge works is you're always merging a branch into you. You're not merging outward, you're merging inward. So you need to be in the branch you want to merge into, and you tell it which one you want to merge in. So this would do it, and this would actually fast forward and apply our change, and it would be in the master branch. I'm not going to do that, though, because I want to show you what a pull request looks like. Okay? So a pull request can happen within a repo from a different branch, or it can actually happen from a forked repo if you're using like a GitHub or a GitLab. You select the base that you want to merge into, and you say, like, compare it with the branch that you want to merge, right? You can put a commit message that represents the merge of this branch. It might not be the same as the commit message that you've most recently used in the branch. Sometimes branches are significant work. You're adding a whole new feature to a project. So you might say, this adds the calendar module. Done. Great. Pull request message, right? So once you put a descriptive header, just like you would with a Git commit, you can leave a body of comments here. If there's something to be considered, you can go through review processes. This whole thing gets into workflow, which we'll talk about in just a second, but I'll just show you the basics. So once I create the pull request, then it will appear in the pull request tab. So this is the same for any one of these different GUIs for Git. This is not something, pull requests are not something that happen on the command line. They are something that is kind of owned by the web interfaces of Git, but they're very, very common, especially in open source projects. If you look at the pull request, you'll see, hey, look, adds well-formatted initial list. And as the maintainer of the code, let's say the guy in charge of the master branch, I could look at this and say, okay, that has no conflicts. That's good. I can see that it is made up of one commit. I can actually look at the changed files and see what's changed here. Oh, okay. And this is kind of a diff view that's showing you left and right, what has changed. If your repo has auto checking stuff, if you have dependency checkers or linting, that can happen within here. It'll tell you if those are all working. And it provides you a conversation tab where I could click this into a review. I could route it through people to sign off on it for, code cleanliness, or, maybe it's not following the naming conventions of things that we're using. Have people tweak it, get it just the way we want it, and then I can merge it in. Once I'm done, once I'm ready, I can either create a merge commit. I could squash all the changes from that branch and add a single change, just like we did a squash before. That's cool. Or I can rebase and merge. A lot of projects live by the rebase, which will basically say everything that you did on your branch, we're going to pretend that applied to our branch linearly. And all those changes happen now in linear time in the main branch. That makes some Git tools work really, really well. Git bisect, most notably, which is, it's a fancy tool for debugging that needs a linear commit history to work really well. I don't like it at all. You can get into flame wars over this. I don't like rebasing, except for in the context that I showed you. I prefer merge commits. I like to see the spider web of activity because it's a true history of what was actually happening. So I'm going to create the merge here, confirm the merge. It's going to be done with my user, and that will actually close down the pull request. So if I go back, it's closed. And because I did it on the remote, that means if we go back here and we look, the master branch now has lists in it. And over here in my local one, we do not. So I can get pull. This is getting pulling, and it's going to yell at me. It says, hey, wait, which one are we pulling? It did the fetch. It fetched okay, but then it didn't know which branch we want to merge with because we haven't specified a relationship between our local branches and the remote. So I can manually just say git pull origin master, and it'll do the same thing. Or I could git fetch, and then I could git merge origin master, just like we talked about before. All right, so we've done a rebase, we've done commit messages, we've created repos, we've pushed, we've pulled, we've done some branch changes. Let's talk a little bit about branching strategies, because that is really important. So this is workflow stuff. There are some major workflows that are out there that people can just pick up and use. GitHub has one, the GitHub flow, which is actually relatively simple. Creating a branch, it talks about what to do with it, and they often will use the pull request methodology that we talked about before. Another really popular one for organizations is Git Flow. This came out, I don't know, what was that, like 2012, I want to say. And they use more branches. They have a long-living master branch, long-living develop branch, And basically, master is for releases. Develop is kind of the linear history of everybody's work getting merged in as you go. All work is done in feature branches, and they're just named that. They don't. I mean, in Git Flow they actually have specific naming conventions for this stuff, but the premise is the same. If you're going to do something, you don't work in develop. You work in a feature branch, just like I did for the lists. You get it the way you want it, and then you merge it into develop. So you might have different developers working on concurrent feature branches. They might have started in the same spot, and they might come back in at different points in time. When you're ready to make a release, develop can push those release branches and get ready, and eventually those release branches, when they are approved to go, they kick over to master and they get a tag, and this is like the public versioning thing. If for some reason you have an emergency, a problem in the master release that you need to address directly, that's done as a hotfix. So you pull it straight out of master, you do it there, and then the changes are reflected back into master immediately and into develop. And you can see the spider web that's happening here. This is a very, very organized, very powerful method of doing things, but it's overkill for a lot of teams that are kind of small. Personally, I like to align my branches. So I do a lot of web development, so I like to align my branches to environments. So I would have master be production, and I might have a branch called stage, which is the staging site. And then I still do my work in feature branches, but I'll merge them into stage, and we'll push them up into stage. Or we might have multiple stages if we're going to be working on concurrent releases that are being reviewed separately. I do a lot of work for pharma, and the review cycles there are very specific changes that are getting reviewed by people, by regulatory and legal people. So you can't just roll stuff in left and right. It has to be part of the plan for each release. So we might have, for some of these jobs I've done, I've had 10 different staging environments that align to 10 specific staging servers, and we'll stage them accordingly. You can use the more descriptive names, but generally the best practice that I think is a takeaway from all of these is, as an individual developer, when you can, create your own feature branch. If you have a naming convention for it, that's great. If you don't, just name it something descriptive. Do your work in there, and nightly push it up to the remote, so that if you get hit by a bus, people can pick up where you left off, or if your computer dies, you have something to go back to that's at most a day old. But clean up your code before you do that push. Do little rebases and make sure you're getting atomic commits that are good and clean, because it'll help you later. It's not like some theoretical best practice here. This is real, tangible. This will help you tomorrow if you do it, and you're going to be really mad at yourself if you didn't. So focus on that. Learn good commit stuff. All right. I think that is pretty much everything. Aligning to environments, feature branches, commits, we talked about that. Organizing them, rebase, we did that. Git flow, we talked a little bit about that. Pushing changes, changing branches, Git fetch versus pull, remotes, distribution, Linus Torvalds, history of Git. All right. So this is definitely I guess I would call it a primer on Git. There is so much more to it. I recommend, if you're getting started, join a tilde community, join SDF, join the tildeverse. There's a bunch of little projects people do all the time. Throwaway things, shell scripts, or you can even use Git for non-code. I keep all my writing in Git. I keep my version history for short stories and books and everything in Git. It's fantastic. It works really well with text. I can roll back and see old versions. I can blow away chapters. I don't care, because it's all there. So just start using it and practice a little bit. If you can work with other people, that'd be great. If you're just getting started, though, and you don't have a team, just use it for yourself, for your own personal stuff, and you'll see how cool it is. Don't get intimidated. Everybody hates the complex terminology. People are generally out there to be helpful with you, and there's just a few flame wars to avoid. The whole merge versus rebase thing is one of them. But for the most part, people are going to be willing to help you out, and just give it a shot. All right. So thanks a lot. If you have questions, if you want me to follow up on this video, if you want to offer a topic for another video, let me know in the comments down there if you can. PeerTube's a little tricky with that sometime. You can also find me on Mastodon. Let's take a look real quick there at where you can find me. Oh, you know what? I'll make it even easier for you. Tomasino.org. That's me. Everything of mine. All right? You want to find me somewhere? It's all there. So find me. Let me know what you want me to talk about, or if you have, cool positive feedback. If you don't, if you've got negative feedback, I don't want to hear it. Don't even leave it. No, seriously. I don't want creative criticism or anything. Just be nice. Cool? All right. Have a good one.